These are examples from the homework practice workbook for section or chapter 5, section 3. So the first set of directions asks us to determine whether the ratios are proportional. And so the way we're going to end up doing that is we're going to take those two ratios and we're going to compare them. And so when I compare them, I want to come up with a denominator that's the same. And so let's take a look at the 5/6 and the 5/18. Well, I look at that and I could multiply the 5/6 by 18 over 18. But I look at this 15/18 and I see a common factor here. And so what I'm going to end up doing is taking out a factor. So let's go ahead and do that. If I take out a common factor of 3, let's take out 3. What we're left with is 15 divided by 3 makes 5. And 18 divided by 3 makes 6. And those two fractions are exactly the same. So what that means is that they are proportional. Now another way to do that is to also cross multiply and use cross products. And so that might be another way that you might be taught. And so if we do that, we've got 5/6, and we're going to set it equal to 15/18. And so cross products work this way. We multiply the numbers diagonal from one another. The 18 and the 5, we multiply those two numbers. So 5 times by 18, and we see if it equals these products, the 6 and the 15. So 6 times by 15. And so when we go ahead and multiply those numbers, we end up with 5 times by 8 makes 40. 5 times by 1 makes 5, plus 4 makes 9. So 90 is what we get when we multiply those two numbers. Here, 6 times by 5 makes 30. So we're carrying a 3 there. 6 times 1 makes 6, plus 3 makes 9. So we get the same numbers. So cross products, or coming up with a common denominator, can prove whether ratios are proportional or not. So this one is a yes. Taking a look at this one here, we could do the same thing. We could either use that method that says come up with common denominators or cross products, your choice. So I'll do them both ways, and then I'll do one way and the other for the next example. So this one here, the 7/10, I see if I just multiply it by 3 over 3, I would end up with a 21 over 30. And 21 over 30, now I have common denominators, and we have to compare those numerators, see if they're the same. See, 21 over 30, and I have 22 over 30. Well, those two numbers, the denominators are the same, but these are not the same. So that means these are not proportional. And again, cross products works as well. So again, you can do this. You can set 7/10 equal to 22 30ths, and then use those cross products. So 7 times by 30, and we would set that equal to, and then we'd do the 22 times by 10. So 10 times by 22. And so we go ahead and multiply here. 7 times by 3 makes 21, and then you bring that 0 down. Over here, 22 times by 1 makes 22. You bring a 0 down here, and you see those are not the same. So either method ends up working. This method's nice. Numbers are a little smaller, but sometimes it's hard to find the common denominator. So we'll stick with the cross products method for the next couple problems and see what happens. So for the next one, again, this one was a no for number 4. Next one here, we'll do cross products only. And so we'll do 7 and 27. We're going to end up multiplying. So let's set up our proportion first. 7/9 equals 24 27ths. So we can use those cross products. 7 times by 27. 7 times by 27. And we set that equal to 9 times by 24. Again, these are the cross products here, 9 and 24. So when we do the work, 7 times 7 makes 49. So I've got to carry a 4. Remember about that. 7 times 2 makes 14, plus 4 makes 18. So 189 is what it equals. When we take a look at this one, we have a 9 times 4 makes 36. So I've got to carry a 3. And 9 times 2 makes 18, plus 3 makes 21. So those two numbers are not equal, so that would be a no. Well, let's use the other method on this one where we come up with that common denominator. So here's the first fraction. I want to make 21 as the denominator, so let's go ahead and multiply this by 3 over 3. And when we do that, see, I'm not changing that number. See, think of this as like a giant 1. And you learned way back in maybe first grade, well, probably not first grade, but maybe like third grade or so when you started doing multiplication, you learned that a number 1 times any number just makes that number. Like 1 times 3 makes 3. 1 times 4 makes 4. Well, here we're treating this 3 over 3 as 1 because 3 divided by 3 is 1. 1 times a number doesn't change it, so that means it's an equivalent fraction. And so when we go ahead and multiply across, I get 9/21. Well, that's not the same as 10/21. These two numbers are not equal. And so what that means is that we have no proportion here. This ratio is not a proportion. So we got 3 no's and 1 yes. Let's take a look at the other set of directions here. It says find a ratio equivalent to each ratio. Equivalent means equal. And so when we do this, we're going to take this ratio here, and we want to multiply it by some number. And again, it's this number 1 that we're talking about, or divide it. So if both have a common factor, we can divide by a common factor. So let's take a small number. So here the answers can vary. So you might have a different answer than your teacher, but as long as you're doing the right work, it's still going to be an okay answer. So let's say we take 2 over 2, because 2 over 2 is 1. So it's this giant 1 that we just talked about. And so 1 times 11/12 makes 11/12. Well, 2 over 2 makes 1. So we could go ahead and multiply those two numbers straight across here. 11 times 2 makes 22. 12 times 2 makes 24. So now what we have is an equivalent ratio. So what we can do then is it says then use the ratio to write a proportion. Okay, so the proportion would just be this. It'd be 11/12 equals 22/24. And that would be your answer. So you could have multiplied by 3 over 3, 4 over 4, 5 over 5, and you might have a different answer here. However, it's the same answer as long as you multiplied by the same number on top as on the fraction as you did on the bottom of the fraction. Well, we could multiply or we could divide. You see, these two fractions, these two new numbers, 35 and 55, could both be divided by a common factor. So we could divide by 5. Now, dividing by 1 is the same thing as multiplying by 1. You still get the same number. So we're not changing the answer, we're just coming up with what we call an equivalent fraction. And so if I do that work, I have 35 divided by 5 ends up giving me 7. 55 divided by 5 gives me 11. And so that would be my answer, 7/11. That is the equivalent ratio. Now again, you could have multiplied by 2 over 2, multiplied by 3 over 3, but dividing by 5 over 5 gives you another equivalent ratio. So our proportion is what the answer in the answer box should be, so that's what we're going to make here. So a proportion is just when two ratios are equal to each other, and that would be our answer there. So again, these answers can vary. So here, I'll multiply this one. This has no common factors, so I can't really reduce it like I did on the other one. So I'm going to just multiply by 2 over 2. I'm choosing 2 because it's a small number. If I pick 3, it's just bigger and the multiplication's tougher. So I'm just going to pick the smallest number to make the problem easier. See, 2 over 2 still is 1. Again, you could pick 3 over 3, 4 over 4, 5 over 5, 10 over 10. You'll get the same answer. It's still an equivalent ratio. It'll just be a different equivalent ratio. So, again, 1 times a number doesn't change anything, so it's just the same answer, just a different form of it. 25 times by 2 gives me 50. So let me fix that. I was about to write a 2. So 50. And down below, 18 times by 2 makes 36. So there it is. 50/36 is equivalent to 25/18. Equivalent means equal, and it's equal because we're multiplying by 1. 1 times a number doesn't change anything. It's the same answer. It's just a different form. And so there it is, our equivalent ratio written as a proportion. So those are the types of problems you'll see on tonight's homework.